Thank you for watching this video. So in this video, we're doing question 6 of May, June 2022, question 12 mathematics paper 1. And these are functions. This is an exponential function. So I'll read question 6 statement and then proceed to answer the questions that follow. So 6.1 reads as follows. Given g of x is equal to 3 raised x. So we are given this equation here, or this function g of x is equal to 3 raised x, exponential function. So there are questions that follow 6.1.1. 6.1.1, write down the inverse of g in the form y is equal to. So you are given this, right? G of x is equal to 3 raised x. So they want you to write the inverse of g in the form y is equal to. So if you want an inverse, of a function, you reflect about line y is equal to x, right? So when you reflect about this line y is equal to x, you use this transformation. X and y become y and x. So you have a g of x, which is y, is equal to 3 raised x, right? So your x and y swap around, which means you have your y, x is equal to 3 raised y. You have applied the transformation now, when you are here. Once you have swapped x and y around, the next thing to do now is to solve for your y. So I want to solve y to be the subderivative from how do you remove y there as an exponent? You use the log functions. So you say log of x is equal to log of 3 raised y, right? So when you have a log and you have an exponent there, that exponent of whatever that you're logging comes to the front here. So you have log of x is equal to y log 3, right? Then you divide by log 3, both sides, log 3. So you have y is equal to log x over log 3. Therefore, your y is equal to log. Done. So this is the inverse of g. Let's move. 6.1.2. A point P lies on this function. So we have a point P, right? Which have the coordinates what? 6 and 11. It is on what? On h of x, which is equal to 3 raised x minus 4, right? Plus 2. So this point P is on this one, on h. Point P lies on h of x. So the graph of h is translated to form g. Write down the coordinates of P on G. Okay, so we have h of x here. So h of x is equal to 3 raised x minus 4 plus 2, right? So they're saying this h of ours have been translated, moved around to form G. So it has been moved around to form what? G of x, which is equal to 3 raised x. That's what happened. So they're telling us that your h have been translated to form G. So now they're saying if P on h was this, if P, which is 6 and 11, was on h, what will be the image of P on the newly translated function? G. So you have that your P here is 6 and 11, right? Which means if you put 6 there, right, your corresponding y value will be 11. It's here. So now they want you to find P prime on this newly formed function that was formed by transforming the old one. So what you should ask yourself what transformations were applied here to move from this point to that point, right? So you say, okay, we move from x is equal to 4, right, to what? X is equal to 0. From x equal to 4 to x equal to 0. This is 4 units to the left. We move from x equal to 4 to x equal to 0. This is 4 units to the left. And then we move from our horizontal asymptote being y is equal to 2 to y is equal to 0 then. This is what? 2 units down. So this is the transformation that occurred here to get to that point. So what happens is your x and y of your h are transformed by x. What is it? And what do you do on the x? You move 4 units to the left, so which is subtract 4 here. What do you do on your y? 2 units down, so it's y minus 2. That is the transformation that is applied on the x coordinates of this thing here. So now, if you're saying your p is 6 and 11, then the image of 6 and 11 will be 6 minus 4 and 11 minus 2. So your image of p is 2 and 9. That will be the coordinates of p on the new function g. So sketched below is the graph of f, which is that have the equation f of x equal to 2 raised x minus p plus q. The t is the point on f, and the horizontal asymptote of f, this one, is y is equal to minus 16. Right? Here's the question. Determine the values of p and q. You want us to find the values of p and q. I'll read this statement again. Sketched below is the graph of f. Here is a graph of f. You can see it's an exponential equation, exponential function. They're saying t, which I've called is 3 and 16, is the point on f. It's the point on f. Here is t. And the asymptote of f is y is equal to 16. So you have a horizontal asymptote at y is equal to minus 16. Determine the values of p and q. You want to find the values of p and q. You know what q is. Q is a horizontal asymptote, right? So therefore, you have a horizontal asymptote with 16. So your q is equal to minus 16. Done. Then now your equation is f of x is equal to 2 raised x minus p, actually plus p, plus q. Our q is minus 16. So the only thing that we are left with to find is p, because we have 16 to be our horizontal asymptote. Then to find this p, we use the point that any point that we have on the graph to find the value of p. The point that we have is t, which is 3 and 16. So your 16 is y, you put it here. 2 raised 3 plus p, right, is equal to 16. Minus 16. Transpose 16 to the other side. You have 16 plus 16 is equal to 2 raised 3 plus p. What is this? This is 32. Is equal to 2 raised 3 plus p. 32 is 2 raised 5. It's equal to 2 raised 3 plus p. In order for these to be equal, the bases are the same exactly. So in order for this to be identical to that, it means this part should exactly be that, which is this part also needs to be 5, the sum of p and 3p. sum of p and 3 also needs to be 5. So we have 3 plus p needs to be 5 in order to be identical to this part, which would mean that transpose the 3 to the other side, p is equal to 2. We have done that. We have the values of p, we have the values of q. Done. And dusted. Easy. We're done with this question.